Welcome to another eddycurrent.com training video. Before we dive too deep into tube testing with the bobbin coil probe, I want to show you how surface testing relates to encircling or bobbin coil testing. Now, typically when you use a simple tester like this happens to be a Nortec 2000D dual frequency. I chose the 2000D because I want to show you what we do for phase analysis when we're using bobbin probes and multi-frequency testers. So typically when you're using a tester like this that has a lot of applications in aircraft, you're looking for cracks with a surface pencil probe. Normally you're looking for absolute signals that just go up and to the left, or they have single polarity. Or maybe if you're doing something that's ferritic, they'll go up and back, but they only have a single polarity. Well, the only reason you have single polarity is because you're using an absolute probe, right? But they also make differential probes. That's commonly what weld probes are. When you're doing surface testing, they'll have differential plus point coils. But this is a self-comparison differential pencil probe that is going to give you the dual polarity signal like you would see on the differential channels with a bobbin probe. So you're going to get an output on your screen when one coil sees something that the other coil doesn't. So it's comparing two parts of the material in close proximity to one another. This type of probe works really good for short flaws. They use similar types of arrangements for bobbin probes and tube testing. So all I have here is an aluminum block with some notches in it. I'm going to take my differential pencil probe. I'm going to balance, and instead of seeing the single polarity response, you're going to see a dual polarity response. You got the down and the up. There, that's better because I have to. With these differential probes, you have to have the probe in the correct orientation to get the maximum response. So I'll try that one more time. I'm going to see erase. And as I scan over the flaws, you get it down, back to null, and then you get it up and back to null. So these look almost identical to the signals from the flat bottom holes in the calibration standard. So what I want you to notice here is these are two different frequencies, right? And there's more phase lag with one test frequency than the other. And that's the power of multi-frequency phase analysis, is that you'll be using multi-frequencies and seeing how flaws behave between test frequencies. So that should take some of the mystery out of bobbin probe analysis for tubing. The only reason you get this type of signal is because you're using a differential probe. And then you'll also have 4 test frequencies usually that also have absolute signals. So you get the dual polarity differential response, and you get the absolute response, which is good for finding things that are gradual, such as steam erosion or gradual wall thinning. So I can easily take a surface probe and hook up to a tube testing instrument, or I can take a bobbin probe and I can hook up to an aircraft instrument. It all depends on, what adapter cable you're using and what type of configuration you plug into the tester. So now that you know that you can get differential signals with a surface coil, and you can also observe phase responses that indicate different depths, this should give you an idea that the tubing's not that complicated. It's just, it's a little bit different. So this is a good place to learn. Thanks for watching.